In this video, we are going to continue with the cylinders. Now here, the question is, find the mass of a metallic hollow cylindrical pipe which is 24 centimeters long with internal diameter 10 centimeter and made of 5 millimeter thick metal. If 1 centimeter cube of the metal weighs 7.5 grams. So we have to find the mass of this metallic hollow cylindrical pipe. Now two things here. One, how do we calculate the mass? We calculate mass as volume into weight per centimeter cube, right? So now it means that we have to calculate the volume of this metallic hollow cylindrical pipe. And we know that if the cylinder is hollow, how do we calculate the volume of the hollow cylinder? How do we calculate? We calculate the external volume minus the internal volume. That gives us the volume of this metal. How much metal has been used to make this cylindrical pipe. Now for that we need the internal radius. We also need the external radius, right? So let's see what all is given to us. Let's first write the data, which is 24 centimeter long. So this gives us height as 24 centimeters, right? Height will remain same whether you are calculating the external volume or the internal volume. Height in both the cases will remain same. Now, what are the two things that we want? We want the internal diameter as well as the external diameter. And from that we will calculate the radius. So since he has given us the internal diameter 10 centimeters, so let's write internal diameter is 10 centimeter. From this we can calculate the internal radius. So we will name that as R, and that is 5 centimeters, right? After that he is saying that it is made of 5 millimeter thick metal. So thickness is also given. So what will this thickness do? It will help us to calculate the external radius. Thickness is 5 millimeter. So we will convert it into centimeters. How? Dividing this by 10. So it will become 0.5 centimeter. So with this thickness, I will be in a position to find the external radius. And let me denote that as capital R, and that is thickness plus internal radius. This thickness will get added to the internal radius and I will get the external radius, that is 5 plus 0.5, that is 5.5 centimeter. Now I have everything. I have the external radius, I have the internal radius. I can calculate the volume of this cylindrical hollow pipe. How? External volume minus internal volume. So let me put all the things in place now. Pi r square h minus pi r square h. This is the internal volume. This is the external volume. As I told you, h is going to remain same. Height is not going to change. So what I will do is I'll take pi and h common. So what am I left with? I'm left with r square minus r square, right? So pi I can substitute as 22 by 7. H is 24 and this capital R is 5.5. So can I make it simpler by writing this as r plus r into r minus r, because this is a square minus b square. This will make my calculations a bit easier. So 22 by 7 into 24, r, that is 5.5 plus r is 5 into 5.5 minus 5. So this will give me 22 by 7 into 24 into 10.5 into 0.5. Right? So if I want to further calculate this, how do I do it? So I have now 22/7 into 24, and this becomes 105 divided by 10 into 5 divided by 10, right? So let me simplify this. 7 ones are 7 fives are, 5 ones are 5 twos are, 2 12s are, then 5 threes are, 5 twos are, so again 2 11s are. So finally I have 33, 11 threes are 33 into 12. This is my volume of the hollow cylinder. Hollow metallic cylinder. Now I want to calculate the mass. Right? Mass is equal to volume into weight per centimeter cube. And the weight per centimeter cube was given to me as 7.5 grams. So I will multiply this by 7.5 grams volume. So mass is equal to volume I have calculated as 33 into 12 into 7.5, that I can write as 75 by 10. So further that can be written as 5 ones are 5, 5 fives are, 5 twos are, 2 6 are. So my mass is equal to 6 threes are 18, 6 threes are 18, and 1 is 19 into 15. So which is equal to 2970 grams. Right? Okay. Now I have another question. In this, he's saying that a well with 10 meter inside diameter. Okay, I have a well like this, and the inside diameter of this well is 8.4 meter. No, 10 meter. Okay, inside diameter is 10 meter. So its radius is equal to 5 meter. Is dug 8.4 meter deep. So what is the height of this 8.4 meters, right? And the earth taken out of this. So when we are taking out earth from this, it is spread all around it to create an embankment, right? Now you can see that you have a concentric circle type situation here. So this is 5 radius of the inner circle, and this is your outside circle, whose width is 7.5. Oh, the width is also given. So this part is given 7.5 meters. To form an embankment, find the height of the embankment. So now we have to find how high this can go, height of this embankment. So what does that mean? It means that we will first calculate the volume of the earth dug from this well, right? After that, we will write the area of this embankment. Now, what is the area of this embankment? Area of this embankment is equal to the outer circle minus inner circle, right? That will give us the area, and then we will multiply that by h to get the volume. So h is unknown. We can find the height up to which this embankment can be raised. So we will continue with the earth. How much earth, volume of earth taken out from the well. So volume of earth dug will be pi r square h, because it's a cylindrical well, right? So that is 22/7 into radius we said is 5 into 5, and height we are saying is 8.4. So let it be 84 by 10. Let's keep it as it is. Now we will find the area of the embankment. Area, or directly we can find the volume of the embankment. Now first let's find area of embankment. That will be external circle, area of the external circle, pi r square minus pi r square. Now this r, how do I calculate this r? So this r can be calculated as from this to this. This to this it is 5, and 7.5 meter width is to be added to this. So this will become 7.5 plus 5. That will become 12.5 meters. Right? And then I have small r that I know is 5 meters. So I can find the area here. I can take pi common. So let me write this as r plus r into r minus r to make my calculation simpler. So I will get pi, r is 12.5 plus 5 and 12.5 minus 5. Right? Now, if I want to find the volume of embankment, that will be this. This is 7.5 into h, right? Now, volume of this embankment is equal to the volume of the earth dug because same earth is utilized here. So, these two volumes will be same. So, let's equalize these. So, we have 22 by 7 into 25 into 84 by 10 is equal to 12.5 pi, that is 22 by 7 into 17.5 into 7.5 into h. So this and this will go. 5 5s are 25, 5 2s are 2, 4s are 8, 2 2s are 4. So we have 42 into 5 equals 175 upon 10 into 75 upon 10 into h, right? So let's cross multiply. I will get 42 into 5 into 10 into 10 divided by 175 into 75, which is equal to my h. Now I need to do the simplification. So how will I do the simplification? 5 3s are 15. So 5 5s are, right? 7 6 are 7 5s are. Then 5 2s are 5 1s are 5 5s are, right? So 3 2s are 3 5s are, 5 2s are. Now I have got 2 into 2 into 2. So my h is equal to 2 into 2 into 2 in the numerator, and what is in the denominator? Only 5. So h is equal to 8 divided by 5, which is equal to 1.6 meter.